Okay, so could you have a look at the screen for me? Like I say, today I want to get this theme finished well and truly. Have we got a rubber? Nikki, could you pass me the rubber plug, please? Thank you. Okay. So today I want to get this theme finished off. So it should be a little bit more practical today. I'll try and get it a little bit more hands-on because I appreciate the last sort of few lessons we've kind of just been looking at the screen and just sort of absorbing information, which is sometimes what we have to do. But hopefully today it will be a little bit more different. So just remind me, so far we have covered, well, what's the first thing that we covered? We looked at measures of central tendency. So we looked at measures of central tendency. Now, what's another word for a measure of central tendency? Can anybody remember? Average, perfect. Okay, so average or measures of central tendency. Okay, now if you remember, there were three types of measures of central tendency. There were three averages. What are they? Perfect. The mean, the median, and the mode. And we spent quite a lot of time yesterday in the lesson before talking through what each of these things mean and also when each thing may be useful. The reason why there are three measures of central tendency is because sometimes one may be more applicable to the other, or one may not be a good measure. Okay? So just remind me, when does the mode start to break down? When would a mode not be a good measure of central tendency in general? Yeah, if we start having more than one, so like 3 or 4 or 5, suddenly this becomes quite a poor measure. The idea of a measure of central tendency is you're looking for one number that best represents that data set. Okay? What about the mean? When does that start breaking down? Good, when there's outliers in that data, because you remember the mean always gets attracted towards those outliers. Yeah? So if you have skewed data, remember I asked you to look at skew in the slides, slides 41 to 50. Okay? Have a look at those slides if you haven't already. So skew is all to do with if the data is no longer symmetric, then the mean starts getting skewed towards those outliers. Okay? The median, what's the median again? Yeah, the one in the middle, okay? Now the median, if you're not sure which one to use, the median is usually a pretty good one to go with. So one slap bang in the middle, but it may not always be the case. For example, if you have data that looks like this, okay? So in other words, bimodal data, the one in the middle will be here. So the median will be there, which clearly wouldn't be a good measure, Is that okay? Good, okay. So that is measures of central tendency. Yesterday, we started looking at measures of spread, okay? And we came up with two different measures, okay? The first one we came up with, can anybody remember? The range, perfect. So what's the range again?
The highest value and the difference between the highest value and the lowest.
Absolutely, it's the difference between the extreme values. So you remember with the example I used yesterday with like the hospital deaths, survival rates, death rates, okay? The range was just simply what's the difference between the highest survival rate and the lowest survival rate. It's the difference in the extreme values, okay? But we also came up with a better measure of spread yesterday. What did we use? Perfect, standard deviation. Okay, so standard, what am I doing in capitals? Standard deviation. Now, if you remember, there was another one associated with this. Can anybody remember what it was? Sorry? Variance, perfect. Okay. What's the relationship between variance and standard deviation?
Standard deviation squared.
Good, with the variance, yeah? So if we say that this is either sigma, okay, or s, then the variance will be sigma squared or s squared. What's the difference between sigma and s? When would we use sigma? When we're dealing with a population, perfect. When would we use S? Sample. If we're just using with sample, perfect. Okay. Can anybody remember the formula for, let's go for the variance. Can anybody remember the formula for the population variance? There's two.
It's 1 over F.
Yeah.
And then sum of X minus
Yeah. x bar all squared. Now, just because I'm dealing with population, okay, I might have made this mistake yesterday, okay, just because I'm dealing with population, I'm going to deal with the population mean, which remember is mu, okay? X bar is the sample mean, okay? What about if I wanted to deal with the sample variance? Perfect, and everything else is the same, right? Except for the x bar. Yeah, is that okay? Now, if you remember the reason why I said n and n minus 1, don't worry about it too much, but effectively, this value, if I just divided by n, would actually be too big, okay? Or wait a minute, no, it would actually be too small, okay? So therefore, I need to do a correction, which is n minus 1, and that just basically makes it more in line with what it should be. Okay, so make sure the sample variance is more in line with what should be happening at a population level. Is that okay with everyone? Okay, so don't worry about this too much. Just be aware there is that distinction there. Okay, so good, good. Now, what is standard deviation? Can anybody remember? What's standard deviation?
The average spread distance from the mean.
Absolutely, okay. So standard deviation simply gives you, it's a measure of spread, it's the average distance, and by average in this case we mean the mean, okay. It's the average distance from the mean.
Average spread distance?
Yeah, spread, distance, deviation, they all kind of mean the same thing. But if you remember, this distance comes from looking at the difference between your individual value and your mean, yeah, okay. And you remember the reason why we square it?
Minus.
Yeah, to get rid of those negative distances. So it makes sure that all the distances are positive. So when you add them all together, there's no cancellations which happen. All good? Yeah? We happy? Good.
So it's the average distance between
Each data point and the mean. Okay, so you look at your data and you say, well, actually, let's look at all the distances between each individual data point and the mean, and let's just take the average of all of those distances. So on average, each data point will be a standard deviation away from the mean. Is that okay? Yeah. So does this make sense with everyone? Does this make sense? Yeah? No issues? So if you're aware of measures of central tendency, mean, median, and mode, we understand when we should use each one and when one might start to break down over the other. And we're also aware of measures of spread, particularly standard deviation. That will come back again and again and again. So you're all happy with these concepts on the board? Yes? No questions? Good, fantastic. Okay, so what I want to do now is start talking about how we can represent data a little bit more. So has anybody seen a stem and leaf diagram before? Yeah? So a stem and leaf diagram is simply a way of visualizing the shape of data. Now, does anybody remember, if I start talking about the shape of a data set, what word do I give to describe the shape of a data set? Begins with a D. Perfect. Distribution. So if I say the word distribution to you, and I know I have used this before, I'm simply saying, what is the shape of my data set? How is my data distributed? Okay. So what I could do, I've given you 3 data sets on the board, 1, 2, and 3. What I want to do is group them together. So I want to group these numbers together in a sensible way so that I can start to see the shape of this data set, right? So can I create some space? Can I rub this side of the board off? Okay. By the way, these formulas here you do not need to remember. They are in the formula sheet, okay? And if you want to find the formula sheet, it's at the top of the VLE page, okay? So have a look in there, and that will give you all of the formulas which you will have in any exam or assessment, okay? So, yeah, so let's take the first data set, right? What I'm going to do is I'm going to group it together in a sensible way. So let's have a look at my data, okay? I've got 14s, 29, 9, 15, 26, 14, 23, 26, 35, and 19, okay? What I'm going to do is I'm going to group it together into tens, okay? So all of the numbers, bless you, all the numbers in the first 10 numbers, so between 0 and 10, I'm going to group together. So can you see there's only one number that fits that category? It's 9. Okay? So what I'm going to do is I'm going to create myself a little stem. Okay? So this stem here will represent the tens, which tens I'm looking at. Okay? So let's have a look. I have the zeros, the 10s, the 20s, and the 30s by the looks of things. Okay? So I'm going to create that. So the zeros, the 10s, the 20s, and the 30s. Okay? And then from there, I'm just going to order the numbers which occur in each of these groups on the right-hand side, and those will be called my leaves. Okay? So as an example, I can see a 9 there. A 9 occurs in the zeros. Okay? And then if I have a look at the 10s, for example, well, I've got 14, 15, 14. Okay? So I'm just going to order those numbers. So I'm going to go 14. I've got 2 of those, so I'm going to separate them with a comma, and a 15. Like so, okay? And then for the 20s, what have I got? I've got 29, 26, 23, 26. Okay, oh, I missed one in the 10s, it's a 19. So I'll just stick him on the end, okay? So go to the 20s then, 29, 26, 23, 26. So I just order those. So my first one would be 3 to represent 23. The next one would be 26, and I've got 2 of those. So I go 26, 26. And then what's the last one? 29, so I just put 29 there. What would go here in my 30s? It'd just be 35, because there's only 35 there. Okay? So can you see that this is a way of representing my data? Here is my stems. It's what I'm grouping my data according to. In this case, I'm grouping them according to tens. So zeros, 10s, 20s, 30s. And then off of there, I'm just ordering all of the numbers that occur into each of those groups. Make sense? Okay? The only thing I need to add though, so these are my stems, these are my leaves, hence why it's called stem and leaf. The only thing I need to add is a key. I need to tell somebody who hasn't seen one of these things for the first time, or perhaps doesn't know how to interpret this data, what I actually mean. Okay? So I'm just going to pick a number. I'm just going to pick that one there. Doesn't matter which one I pick. Okay, I could have picked this one, this one. I'm going to go for that one. Okay? And I'm just going to say, this is what this means. So I'm going to go 2, and then the 6, so that thing there, that will equal 26. Okay, so it's a way of kind of decoding what's happening here. Does that make sense to everyone? Okay. Now remember, you don't have to group them according to tens. You could group them according to hundreds, or you could group them according to 0 point something as a bottom one. As long as you make it clear how to decode it, it doesn't matter. So can I give you 5 minutes to have a go at creating stem and leaf diagrams for the bottom two? Okay, so I've put an example of how you could group this data for both of these data sets at the bottom on the board. Okay. Now, by the way, this is not the only way that you had to do this. Okay. For example, for the first one, some of you may have grouped it according to tens again. So you may have gone for all of the ones in the hundreds, and then all the ones in the 110s, and all the ones in the 120s, etc. You could have done it that way. I've just gone for the hundreds. It doesn't matter. Okay? Doesn't matter. Okay? Likewise, for the bottom one, I've just chosen to do the 0 points, then the 1 points, then the 2 points, then the 3 points, and 4 points, and 5 points, and 6 points, etc. Okay? You don't have to do it that way. You could have done it a slightly different way if you wanted to, but that's just how I've chosen to do it. Okay? So if you've got something different, but you still think it makes sense, that is totally okay. Right? I'm just showing you one way of how you could group the data. The most important thing that you need to add is this key. If you don't tell the reader, if you don't tell somebody who's going to come along and mark your work how to interpret the data, you're going to lose marks. Does that make sense? Okay. But can you see why, particularly looking at question 2, or dataset 2, can you see why it makes sense to represent your data in this way? You can suddenly start to see that the most popular category are the ones in the 200s. Yeah? So you can start to see the distribution of the data. For example, there's a few down here, okay? There's a tall one over here, and there's a few down here, okay? So you can start to see the distribution of the data. Likewise here, it's kind of all equally likely, then there's a dip, and then there's sort of slightly less likely down the bottom there, okay? So you can start to see the distribution of that data set. That make sense? Good, fantastic.